This video, we're going to work on a real-time data engineering project named Real-Time E-Commerce Insights. But this isn't another side project. This project simulates a real-world data pipeline end to end. And I'm going to walk you guys through all the steps from streaming the data in Azure Event Hubs to pulling the data out of warehouse and creating a dashboard in Power BI. By the end of this project, not only you guys will understand how a real-time data pipeline works, you guys will also showcase cloud tools like Azure, Power BI, PySpark, and many more on your portfolio. By the way, I'm Jay, Master's graduate in Data Analytics from Clark University, Massachusetts, USA, and I created this channel to document all the projects that I work on from now. So if that interests you, don't forget to follow. Let's dive right in and get started. So, our project title is Real-Time E-Commerce Insights and Sales Forecasting. In this project, we'll be collecting the transactional data, which we simulate them as a real-time data. So we get a transaction for every 2 seconds. In that transaction, we'll be capturing order ID, time, and amount spent, and total items purchased, and also the location of the order. So that's the process, and these are the tools we are going to use. For the cloud platform, we're going to stick with Azure for the whole project, and in particularly, we're going to use Event Hubs as a streaming platform. We need to use a streaming platform because our data will be changing over time. We'll be producing a transaction for every 2 seconds. So to simulate it as a real-time data, so we need to stream the data first. So we need a streaming platform. So we chose Event Hubs as a streaming platform, and we use Blob Storage. We use that as a data lake, and later we push that into SQL warehouse, which is a data warehouse in our project. And then we use Databricks as a data processing tool. And for processing, we'll be using PySpark. So if you're familiar with Python and SQL, PySpark is kind of a combination of both. So it is easy if you know Python and SQL. So we use PySpark for big data. So Python can't handle big loads in real time. So we use PySpark, and it supports parallel node processing. So it makes the data to process faster and reliable. And we use Kafka as streaming engine, and we use Power BI for visualization tool, and we use Python for scripting, coding, with Faker and Kafka Producer. We are using Faker because we are generating the data. We're not getting the data from a data source like Kaggle. In our project, we'll be generating the data using Faker. We'll be generating the fake data. So we are using Faker in this project, and then we are doing bash script for the Git version control. So we use GitHub and Git CLI for version control in this project. And for the storage format, we'll be storing the tables in Delta table format. So basically, Delta tables are similar to CSV or JSON, but they're more reliable for big data. So Delta tables are a combination of Parquet files and transactional logs. So Parquet file is nothing but a data storage file like JSON and CSV, but Parquet files are reliable for big data processing because they are relatively take less storage, and they also save the data types of that particular column, whereas CSV and JSON doesn't support that feature, but Parquet files also saves the data types of that column. So we use Parquet files in this project. And then the transaction logs is basically for the version control. And architecture, we're going to divide the architecture into 3 parts: bronze, silver, and gold. The raw data will be stored in bronze data lake first, and then it will be cleaned and then stored into silver, and then it is transformed and we do some aggregations and the business ready data will be stored in gold and later on pushed into SQL warehouse. So these are basically the tools that we're going to use. And the tools that you need to install in your system are Power BI desktop, and you need Python on your system, and then you need Git bash. This is the whole architecture we're going to follow in this project. So first comes the data source, where we get the raw data from. So we're going to use Faker for that. And then to stream that real-time data, we're going to use Event Hubs as streaming platform. And Kafka as streaming engine. And then the data that is streamed only stays there for a few hours. So before data removed, we need to pull that data and process it. So we use Databricks for that, for the data processing. And throughout the data processing stage, the data will be stored in the data lake. And the data lake is partitioned into three parts. Like I said, bronze, silver, and gold. So the bronze stores the raw data, and then the clean data will be stored in silver, and then the transform and business ready data will be stored in gold. And later on, it will be pushed into SQL warehouse and then pulled into Power BI to create dashboards. So that's basically the architecture, the whole architecture of the project. Okay, so let's head to the first step. So firstly, we need to produce the data. So I basically had a conversation with the ChatGPT to write a code to produce fake data. It took me a few minutes, and this is the code that I got. And by the way, all the codes and commands that I use in this project will be store all this in the GitHub, and I'll post the link in the description. You can download it. So this is the code. Well, ChatGPT wrote this code, but we need to understand what ChatGPT is doing in this code, right? So it's basically importing JSON, random, and time and date time, Faker and Kafka producer. And it assigns Faker off to fake variable. And then this whole part is just the configuration to connect with the Event Hub, the streaming platform. And then we created a list of categories, and we created a list of locations, which include city, state, latitude, and longitude, which are just coordinates. And we defined a function named generate order, where we did location equals to random.choice. By the way, random has a few functions in it. So random, there is random.choice, random.uniform, random.randint that we used in here. So basically random.choice is choosing a random object from a given list, and random.randint is choosing a random integer from a given range, and random.uniform is to choose a decimal value, a random decimal value from a given range. So here for the location, we're choosing random.choice. So it chooses a random object from the locations. So chooses one of the object from this, which is one of the dictionary from this list. And then the category random.choice as well. So it chooses one of the categories, and price. So let's talk about this first. Like I said, random.uniform is to choose a decimal value from in the range of 10 to 2000. So this does that from the range of 10 to 2000. It chooses a random decimal number, and then the decimal number can be of any length. So we round it up to 2 using this function. So it rounds up that decimal value to only have 2 decimal point numbers. So that is the, and we have quantity, which is random.randint. So it picks a random integer from the given range 1 to 5. And then this function returns order ID, which is fake.uuid4. So this is a method to create a unique a random fake ID. So it creates a unique ID for every single transaction. So this is how we need to do that. And then the timestamp datetime.utc now. So UTC now is the time that the record is created. And ISO format, this is the format of the time that needs to be. And the customer ID, the same, the fake.uuid4 to create a unique ID for them. And the category, price, and we do total amount, which is the multiplication of price and quantity, and round it up to 2 decimal points. And then city, state, country, and the coordinates, and the delivery status, random.choice. So this is the function that we use to generate the fake data. And this is a function to return to produce the data. So if name equals main is basically to make sure this code is ran only when we use this code as main and not call this function into some other one. It's basically a core concept where it's hard to explain, but you'll understand when you research about it. So it's basically making sure this code will be run only when you run it as it is and not call this code into another code. So it is just making sure this code is the main and not called into another function. And then it prints this static string, and then it opens an infinite while loop. So this while loop iterates until we close that code, close the processor. So, and then this infinite loop starts with event equals generate orders, which generates a fake transaction, and producer.send is to send the data to the stream, to the event hub name that we given at the top here, and the value should be event, which is the generate order, which is a fake transaction. And then it prints send. Send is a static string, and then it prints the event that we sent. And time.sleep of 2, basically we're saying the code, saying the while loop to iterate for every 2 seconds. So we're producing a transaction for every 2 seconds with that with this method. So this is basically the faker code. So now let's go to Azure account. So if you don't have an Azure account or you don't know how to start the free trial, here's the thing. You just need to go to Azure free trial, get to this page, create your free account. When you click on start free, you need to enter your details like email ID and your name. You also need to put in your credit or debit card details in it. But Azure won't charge you because they offer a free trial for 12 months, and they also offer $200 worth of free credits that are valid up to 30 days. But they take your card details just for the security. If in case you ran out of your free credits, the $200, before charging you anything, they ask you, if you click yes, you'll get charged. If you click no, they won't charge you, but the services get stopped. I mean, you cannot use any paid services after you exhaust your free credits, the $200. So you just need to put your credit card details in and your information, and you're all set. After that, you'll come to this page. This is the home page of Azure Cloud Platform. So this is where you get into. And when you click on this 3 lines and go to cost management plus billing, you'll see the expenses that are charged for you. Currently, they're using the credits from my free trial credits. So I got charged for 83 rupees, and I also used 4% of my free credits, and they will be expired in 19 days. They actually give you 31 days, but it already been 10 days since I created this account and put my card in, so I only have 19 days left to use this 16,000 rupees. So that's where you see the cost and billing that you're getting, and head back to home. So in our architecture, our first part is data source. So we have the faker code that we need to run. So we have that. Now let's create the Event Hub, the streaming platform. So for that, we go here, search for Event Hub. There it is. Before we create an Event Hub, we need to create a namespace. So we create namespace. Subscription, mine is Azure Subscription 1. For the resource group, since we haven't created any resource group, we need to create one. So let's name it something. RG. Have a look right here. Just because I don't forget anything. So I have for the name. So RG e-commerce real time. So I'm going to name it that. Whatever you name it doesn't matter unless you remember it. So that's what I name it. And then for the namespace name, I name it e-commerce namespace. For the region, you have to be careful. You cannot pick, because I'm in India, I tried picking South India, but I got a problem when I tried to create a SQL warehouse because South Indian servers doesn't offer you much services. So it's always better to go for a West country, but it shouldn't be so far from your location because you get problems streaming into that. So I personally chose West Europe because it has all the features and it's not so far. And for the pricing tier, we cannot go for the basic because basic doesn't support the Kafka features. So we need to select standard. And the throughput units, you can just leave it for 1. Basically, throughput unit is the data that you will be streaming. So 1 throughput unit is basically allows you to stream 1 megabytes per second, which is more than enough for in our case. So I'll just go with 1, and we don't enable auto inflate. So this option is because if your data exceeds 1 Mbps per second, it automatically increases the throughput units to 2. So this is it, and we create it now. It takes a few minutes to create. Oh, first, it needs to validate first, sorry. So after validation, we create it. And it is initializing the deployment. It takes a few minutes, like I said. So while this is in process, let's go do another thing here. First, go to command prompt, and then you click pip install Kafka. We're basically installing Kafka and Faker into it. Kafka, Python, and space Faker. So we're installing Kafka and Faker. Because I already installed it before, it says requirement already satisfied. So that is that, and you need to install that first. Okay. Okay, so the deployment is complete. And now hit go to resource, create Event Hub, and name it. Let's name it e-commerce orders. Partition count 1. Cleanup policy. Delete. So retention time 1 hour. Like I said, streaming platform can only hold the data in it just for a few hours. So in our case, it's 1 hour. 1 hour is more than enough to hold the streaming data. So because we pull the data out with the Databricks. But if you want more, you can just put more hours in there. So basically Azure allows you 168 hours to hold the data in Event Hub. And then now we hit review, let's create. So the validation is done, and create the Event Hub. Yep. Now the Event Hub is created. Namespace is here. Before going further, we need to create our Git repository and initialize the Git in our system first, because we need to do the Git version control. So we open the Git bash that we installed, Git bash. We create mkdir. So mkdir stands for make directory. So we are creating directories. Real-time e-commerce insights Azure. So we are creating a folder, creating a directory named real-time e-commerce insights Azure. So we created it. So what we did here is we created a folder named real-time e-commerce insights. In the path C drive, users, and your username. In my case, it's JC. So let's go and check it out. So in C drive, users, JC. So we created the folder, real-time e-commerce insights, but for now it is empty. But now let's go ahead and create a few more folders inside that directory. So CD, e-commerce insights, Azure. Wait. Oh, spell it wrong. Wait. So I spelled the folder name wrong. I put an extra hyphen here. So I need to do that again. Real-time e-commerce insights Azure. So CD stands for change directory. So we're basically inside the directory now, inside the real-time e-commerce inside Azure directory. And now we're going to create some more folders inside that mkdir, and we name it Databricks notebooks. So this folder to store the code that we are going to run in the Databricks, and another folder called simulator. So, and this folder for to store the code that we use to produce the fake data, and then we do Power BI. Power BI. This is to store the Power BI file. That's it. So we created these 3 folders inside the real-time e-commerce insights folder. So basically these 3 folders are empty because we just created them. And now we initialize the Git inside this repository. For that we do git init. So we need to initialize any repository that we created in our system to make it your local GitHub. So you guys might be, I think you guys are well known about the GitHub. So this is basically creating a GitHub in our PC first. So at the end of the project, we'll be pushing this into the real GitHub online. So basically we created that Git in our system. So we initialized it. So if we initialize it successfully, this folder will be created in that repository. And then after that, we create a README file. Touch README .md. .md means markdown file. So README is just like a README file for our Git repository. So touch used to create a file and make directories for the folder. Like make directories for the folder, touch is for the file, to create a file named readme.md. So here, like you see, we created a readme.md file here, and we do git add dot. So the whole files and folders that we created here will now be stored into the Git. And then after that, we need to git commit with a message. Let's say initial folder structure. So we're committing the changes like we commit in SQL. We are committing the changes using git commit with this flag -m. We use this flag to put in a message. So we're committing the changes with the message initial folder structure. We did that. So we're done with that for now. So we created the Git repository, our local Git repository, and we initialized everything. Now we can go ahead. Let's close the Git bash here and go ahead. And the code that we got from the ChatGPT here, we need to enter a few details for the configuration for our Event Hub that we created. So first we need the namespace host name. So we head to e-commerce namespace that we created, and the host name will be in the overview section, and it named as host name right here. So we need to copy that. And go into our code, we paste it here. And the semicolon 9093 is the port that we use to connect the Event Hub. So basically 9093 is the only port we are supposed to connect to the Event Hub using Kafka. That's the number we need to use. And then we have Event Hub connection string, which is our connection string. So we head to namespace again. And in the left pane, you see an option called settings. Under the settings, we can see shared access policy. We hit that. And root manager shared access. Here, we need to copy, we have a bunch of codes here, but we need to copy the primary string. So we copy that. It can be primary connection string or it can be secondary connection string. In case one of them fails, you can use the other one. So we copy the primary one, go to the notepad, paste it here, and then we need the Event Hub name. For the Event Hub name, so we go to the overview section again, and the Event Hub that we created, and we named it e-commerce orders. So we just need this name to be pasted here. And that is it. And we just need to leave the rest of it like that, and we go click save as. We save it in the folder that we created, the repository, users, your username, real-time e-commerce, into the simulator folder, and change the type as all files, and import JSON, change the name as data producer or generate order. Let's say generate underscore orders dot py. This is a Python file. Make sure you put a dot py at the end of your file name. So generate orders dot py and save type as all files, and encoding should be UTF-8. Save it. So we created that now. So we have the code to generate the fake data. We have the streaming platform, and the Kafka is in our code. So that is used as a streaming engine. So all we need to do right now is just open your command prompt or any environment, any prompt. Open that and choose your file path here. Basically, where we stored the data at. So I stored in the simulator like we saw, and we click here, we copy the path the file is in, and we go into the command prompt, we click cd, which is change directory, and cd space paste the path here, run it. So this is successfully in that path right now. And to run the code that we written, we need to use this. Say Python. We specify the type. Say Python space file name generate orders dot py. That's it. So So now it is successfully running the code. We are generating the data. So we're generating one transaction for every 2 seconds here. To make sure your data is streaming into Event Hub, it shows in the overview section, these charts will display the number of events that are recorded every minute. So there you go. The spike is going up now. That means we are successfully streaming our data into the Event Hub. So now it says 6 events, which will be more than that. The spike still goes up, I guess. You can also see that in the Event Hub as well. It says 6. So now we're done with these two steps where we generated the data and we're streaming it on the Event Hubs using Kafka. Now we need to pull that data out for the data processing, and we also need to store them in this data lake. So before going on to the next step, which is data processing, we need to do one more thing. So we need to push the generate orders.py code into the Git because it is running. So we need to go to open the Git bash and do cd space real-time e-commerce insights. Cd space real-time e-commerce insights. Azure real-time e-commerce insights Azure slash simulator. And then we do git add. We need to add the generate orders file. Oh, let me delete this first. So we need to add the generate orders.py file into it. So git add generate orders.py. Hit enter. So that is added. And now we'll git commit with a message is -m negative. Say data generator code. Hit enter. So that is done. Close it. And now let's go to Azure and create a storage account first for the blob storage. So open that and open search and click storage accounts. Create storage account. The resource group should be the same as that we created before. So this is our resource group, and the storage account name, for the storage account name, let's say e-commerce storage, and I'll put my initials of my name at the end, JK. So that should do, and the region should be same, that is West Europe, and I'll leave the primary service now. Performance chose standard because premium cost a lot of money. So I chose standard for this, and redundancy should be locally redundant storage, LRS. That's it. Click review plus create. Validation's done and hit credit. So create. It might take a few minutes for that. So now the deployment is completed. Hit go to resource, and now we need to create a container first inside this storage account. So on the left side pane, open the data storage settings and hit containers. And here click add container. Let's name it e-commerce. Just e-commerce. E-commerce should be fine. And create. Open the e-commerce container. Now we need to add 3 directories inside this. So first one's bronze, silver, and then gold. So let's start with the bronze. Bronze. Click OK. And here you need to remember, in order for you to see the folder, you can't just create the folder and leave it, because when you go back to the container, you can't see the folder here. So when you create the folder, say bronze, you need to add any file. You need to upload into this folder in order for you to see it. So I'm gonna go ahead and create a notepad file. Let's say an empty notepad file, and save as in the simulator. Let's say temp. So I just created an empty temp text file. Now I'm gonna go ahead and upload it on that temp. So now when you go back to the e-commerce container, you'll be able to see the folder. So unless you add a file into that folder will not be visible to you. So let's do the same with silver and gold too. So add silver now and upload same file. Same for the gold. Upload. So now we successfully created the 3 folders inside the container. So we have the blob storage ready. And now let's go ahead and create a workspace for the Databricks. Now go to the search bar and click Databricks. And here click create, and the same resource group that we created before. And for the workspace name, let's say e-commerce Databricks. So e-commerce Databricks. Region should be same. And for the pricing tier, don't choose standard or premium. Try to choose trial, premium, 14 days, because the standard tier or the basic or the standard tier doesn't have SQL features inside the workspace. So we need to choose trial period. So Azure offers 14 days free trial period for any Databricks workspace. So you can use it for free for 14 days. So go ahead and choose trial premium 14 days. And now hit review plus create. And now create. So, and creating a Databricks might take much longer than the event hubs or storage space. While this is still in process, let's go ahead and delete the temp file that we created inside the simulator folder. So we deleted that file, just not get confused over it. And finally, the Databricks is deployed, the workspace is deployed. Now hit go to resource and launch workspace. And this is the UI of Databricks. So before I said we need to choose a premium tier rather than standard because like I told you, we cannot have the SQL features in the standard tier, which means you don't see this menu in the standard tier. You cannot use SQL features in that. So we need to choose premium for our project because we are going to use SQL warehouse as our data warehouse after this. So we need it. So we need to choose 14-day free trial. And now let's go ahead and create a cluster first to work on. So go to compute on the left pane and here create compute. And for the compute name, let's say e-commerce e-commerce cluster, e-commerce cluster, policy unrestricted, leave it as is, and be careful, never choose these options unless you are ready to pay money because machine learning and photon accelerations draws a lot of charges. Charges you more. So make sure you turn it off unless you need it. And for the Databricks runtime, I'll leave it default. And then for the worker type, so what is a worker? What are a worker? So there are drivers and workers in this cluster. So driver is like a brain of the operation and workers are the one who does the heavy lifting for the driver. So it's basically like a manager and an employee, a regular employee relationship. So manager divides the work between the workers and the workers do the job. So it's the same thing. Here, in our case, there's just one driver who divides the job between the workers, but we can have more workers. Depends on how fast we need the work to be done. So that particular driver passes our PySpark code that we do and divides the work between that nodes or the workers equally to make the job done faster. So we can specify that how many drivers we need to use, but we can specify how many workers we need to use. So here because we don't need to have many workers because Databricks is so expensive. So we need to know how to use, how much to use for our data, for our requirement. So for my requirement, I don't think I need to make the process faster. So I'm going to go ahead and choose single node. That means one driver and one worker. So it's just one worker. And I choose single node here. And for the node type, this is like how this also depends on how fast or how much data you're working on. So let's say for my preference, I'll go to the lowest one, which is standard F4S, which has 5 gigabytes of memory and 4 cores. That is the lowest specs system that we can get. So I'm going to choose F4S in single node. And for terminate after, I'm going to go ahead and choose 10 minutes. So this is like basically preventing over usage of the cluster, overcharging. So if you haven't used the cluster for 10 minutes, if the cluster stays idle for 10 minutes, it will terminate by itself. So you won't get charged. So I'm going to go ahead and choose 10 here and hit create. So after a few minutes, you'll see this green dot, which means your cluster is active now. So let's go ahead and create a notebook first. Now click New on the left pane and hit the option Notebook. Now we need to process the data. So first we need to take the raw data that is on the stream and we need to ingest it to the bronze table first, bronze tier table. So first we need to rename this notebook. So let's rename it to 01 because this is the first step in the data processing stage. So let's say 01 stream and orders, stream orders to bronze.py. So for most of the PySpark code that we work on structured data, we need these two libraries to be imported, which are from PySpark.sql.types import all, import asterisk, and then from PySpark.sql.functions import all. So we imported all the types and all the functions from PySpark SQL. And now, before going ahead, when we import the data from the stream, the data will be in binary because we converted the data to binary to stream it through Kafka. So we need a schema to assign to the data that we get. So we need to create a schema first. Schema equals, this is struct type parenthesis and square bracket. Let's say struct field of, and we need to watch for the columns that we have in our data set, the record. So we have order ID as our first column. This order ID, and we need to define the data type. So we're using faker.uuid4, which generates a fake user ID, and the ID will be a combination of strings with the integers. So basically we can say this, we can define it as string type, say string type of a parenthesis and parenthesis comma, and let's just copy this line for the rest of the columns. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 more columns. 3, 4, 5, 6. So we paste it 13 times. And now for the second column, we have timestamp. And timestamp is also string type, so we'll leave it like that. And the third column, customer ID. And for the fourth column, product ID is also string. Category next, and category is also string, but the price is not string. Price is a decimal value, so that should be double type. So that should be double type. And then next, quantity, that's integer. So that should be integer type. Integer. Then for the total amount, oh my bad. So total amount should be, that's a decimal value because it is multiplication of price to quantity, so the output will be decimal value. So that should be double too. That should be double. And the rest of all should be strings. So just copy paste them here. City, state, country, latitude, longitude, state, country, latitude, longitude, then have delivery status at the end. So now we have a schema designed. So let's go ahead and connect to the event hubs first. So to connect, in order to connect to the event hubs, there is a syntax for the configuration we need to use. So I got this configuration after I asked ChatGPT. So this is basically the configuration you need to use in order to connect to Azure Event Hubs. So we just need to replace these three with our values. So first one is namespace hostname, which we go to namespace and hostname. This is the hostname, so we replace it with the hostname, and then the next one is event hub name, and the event hub name is e-commerce orders, and then event hub connection string. So for that, we need to go to the left pane, shared access policy, root manager shared access key, and the primary connection string. We copy that and paste it here. And we don't need to change this anymore. But I guess we can add a few lines to this one. So let's say starting offsets, quote, and colon, latest, colon, comma, and also add fail on data loss. False. And I don't think we need a comma there. So with these two lines, we're adding to the configuration. We're saying PySpark, the offset, we're defining it where to start. So we're saying latest, so which means only use the data, use the records that are uploaded newly and not the old ones. So after we run the code, it only takes the data that is generated after we run the code, and not the old data that is already on the stream. So it just takes the latest data, and there are a few more methods we can use. We can do earliest rather than latest. So the earliest takes the data, takes the data from the beginning of the stream. So, but in our case, I'll prefer latest, just the new data that is occurring to the stream, and fail on data loss. So this one, if there is any uh, data loss, we're saying the system not to fail and move on to the next record and not just crash. So that's, it's just a good practice to use that. So here we're done with the configuration here, and this is the schema. Let's name it schema. Schema of dataset. Sorry, dataset. And name this. These are just headings. Let's say libraries. Or let's say imports. And then, so next one after that, we move on to reading it. So we have connection to the event hubs now. So we need to read the data from the event hub stream. So next one should be, let's say, stream from event hub. So let's say we name the variable as df underscore raw equals parenthesis open spark dot read stream. So we're saying Spark to read the stream, and in which format? In the format we specify in which format data should be read. So we say Kafka parenthesis close. Next. And then we say option options. It should be options. We say options because we are passing all the key value pairs. We say options here and brackets EH KCON. Oh, so we have to do asterisk EH underscore CON F parenthesis and dot LOID load F. So here we are creating a variable named df underscore raw, and we're saying Spark to read stream in the format Kafka, and the options. So options are basically a key value pair, and we are passing the configurations for the event hubs in that options. But instead of using options multiple times for every single line of configuration here, we are doing a dictionary. We created a dictionary which is named configuration here, and then we are calling it into this using two asterisks underscore configuration. So it's basically another way to write dot options for every single line here into one line, which looks good. It's just for the readability. So that's that, and then we say load to load the data from the read stream. From the stream. So we're done with the reading stream. So the stream we read, the stream we read is in bytes because we stream the data in Kafka in the form of bytes. So we need to convert it to string. For that, let's say heading parse JSON from Kafka stream. So let's create another variable named df orders. Let's say df underscore raw dot select expression, I think expr, okay, expr, parenthesis open, say cast of value as string, parenthesis closed, as JSON, quotes, parenthesis close, and under that we do dot select from JSON of JSON code schema of dot alias of data code parenthesis and dot select of data dot star code parenthesis. So here, so we got the bytes from the stream and we need to convert it to string. So with this one, we say from the take the data from df raw and use this expression on it. So we do select expression, say cast the value in the bits in the df underscore raw, which is binary. So cast that binary data as string. We're saying we're passing the expression, convert it to string. I mean, cast it to string, and call it with the alias named JSON. So we are aliasing it with the JSON, and then after that we do dot select of from JSON function with and we pass the JSON alias, which is the string that we converted from the binary, and we define the schema that needs to be used, which we already created it at the beginning. So we're defining the schema that needs to be used, and we're aliasing it as data. And then we do dot select of data. So this line is basically used because until this line, we converted the binary into string with this line. And then in this line, we are defining the schema, which is this one. After defining the schema, the data will be comma separated, just like the schema, like this, just a list of comma separated values. But it needs to be in columns, like a data set, like a real data set needs to be. So it needs to be separated. For that, we do dot select of data dot hashtag, which means which is equivalent to writing which is equivalent to writing data dot order ID, data dot timestamp, and all the vice versa, all the columns. So instead, we just write that in one word, say data dot asterisk. So that applies for every column in that data set. So basically in this line, we converted that flat record into a column separated record. So we did that, and now, so we're done with the conversion. Now we need to we need to ingest it into the bronze table now. So for that, first we need to have the configuration to access the bronze table, bronze repository. So for the configuration, the syntax I got from ChatGPT is this. So this is the syntax for the configuration. In this syntax, we just need to replace this with storage account name and the access key. So let's head to the Azure, go to storage account and storage account name. So we replace this with the storage account name, and for the access key, we go to security plus networking, access keys, and then here we click show on the key one, we copy the key. Here we are using key-based access to get the access to the storage account. There is another method to use, which we can use string-based access to access the account, but here we're using key-based access. So we have that configuration done, and then this is the syntax to specify the path. So we have the access now, but we need to specify the path where the data needs to be written. So let's create a variable called bronze path, and copy this here, replace this with the container name, and replace this with the storage account name, and this with the final folder path. So we go to the containers. First we go to the main page of the storage accounts from here, and here we go to containers. Open the data storage and click containers here. And what we need the container name, which is this. So e-commerce, we copy paste it here, and then we need storage account name. And for the storage account, this is the storage account name. And then the final folder path, we need to insert that data in bronze path, in the bronze repository. So we do that. So we specified the path the data needs to be written. We have the access to that, we configured it. So everything is done. All we need to do is write it. So now we specify the write stream here. So for that, open a parenthesis, df underscore orders. So the data is in df orders. So we say df underscore orders dot write, capital S, write stream, and dot format of delta, and dot, so option of checkpoint location code, say bronze underscore path plus slash underscore, let's name the checkpoint folder as slash underscore checkpoint as the folder name, parenthesis, and dot start of bronze path. It's separate them just to have the readability of the code. We separated them to a separate lane. So here we're writing the stream which is in the df orders variable, and in the format delta, which I talked before. So the delta format is basically saving the data in Parquet plus transaction files, and plus transaction logs actually. So we define the format here, and then we say option. Like I said, option is a key plus value pair. Here the key is checkpoint location. So this key is basically used to checkpoint uh, at to checkpoint where the data, where the process is. Let's say the stream has 10 records in it and we processed 4 records. So for every record, the code checkpoints that particular record. So let's say if the system ran the 4th record and it is about to run 5th record, but the system crashed. So you need to restart, rerun the code. So that's the PySpark don't run the record from the beginning, from the first record. It starts on the 5th record because it checkpointed at 4th. So that's how the checkpoint location works. It just makes sure the code, if the code is rerun, it doesn't run from the beginning. It starts from the point where it stopped before. So that's how we use this. And those checkpoint logs will be saved in this path. So the bronze path, which we already defined, bronze, so it creates a folder named checkpoint, and the checkpoints are created in that, are saved in that checkpoint folder. And then we do dot start of bronze path just to start the write stream. So I think this is it for the bronze, for the step 1. So now, because we've done this, we need to connect to the cluster now. Like we say, the cluster is deactivated because we put the timing as 10 minutes for the cluster. So we exhausted the 10 minutes time. So we need to reactivate the cluster in order to run this, to connect to that cluster. So we need to go back to the compute and activate, which is this, start the cluster again. So it takes a few seconds to turn on. So now the cluster is active. Let's head to the workspace and the notebook that we're working on. And here in the right side corner, click on connect and the cluster where we need to connect to. And now we're connected to the cluster that we are working on. Now run this code. Oh, there is an error. Oh well, so here's the beauty of Databricks. It suggests the right syntax. So we just need to go accept and run. Here this PySpark is case sensitive, so I can just write the read stream all in lower cases. S should be in uppercase. So that's the error here. Click accept and run. Oh, there is another error. So there's one more error here. It says operation failed. This endpoint does not support blob storage events or soft delete. Please disable these account features. Would like to use this endpoint. So it's suggesting me to disable the soft delete on the blob storage. So this is a basic error, so we can fix it. Now let's head to the storage account. Left pane, go to data management. In the data management, click on data protection. So here, disable all the options here. Enable soft delete for blobs, enable soft delete for containers. So disable both of them and hit save. Saved it. Think now the error should be fixed. There you go. So it started working. So to track the data and confirm the data is inserted into branch table, let's go ahead and create another code block. And let's say df branch as a variable name and say spark dot read dot format, and the format is delta dot load of branch path. Say display of df underscore branch. So if you run that, we have to see a table, the data set, the whole data set with the data in it. So there you go. So by this, we confirm the data is inserted into the branch table. And now so there is a problem with the latitude here. So there should be an error with the latitude here. You have to change it here. I spelled the latitude wrong. That's why I copy paste it most of the time. So we're going to interrupt it first. And we have to change it to latitude to the right spelling. In this case, it's better to delete the data that is in the branch tier table, and reinsert them again. So let's head to the branch table here. Commerce, branch. Let's just delete everything. I'm going to just delete the whole thing. Yep, snapshots too. So this file, and recreate that a directory, branch, upload. Now run the code again. Now run the string. There you go. So the jobs are changing. So now the code is running successfully. But let's run the code to see how many records that are pasted. So now we have the latitude values as well. So they're not null anymore. So we got all the values for the latitude. Oh, we got 119 records copied into the data. Now we are done with the bronze path. I mean the bronze tier values. Now it's time to head to the silver tier. In the left pane, click Notebook. And then name it 02 because that's the second step. Say cleaned values silver. Same with clean values silver, and connect it to the cluster. And we need to, like I said, we need to import the two basic libraries that we need to use when we deal with the structured data. They are from PySpark.sql.python types, import asterisk. Oh, I think, and then from PySpark SQL functions import asterisk. So these two are the basics. Let's put the heading for that as imports. And then, so we imported the libraries that we need. And the first thing we need to do is we need to specify the path that we need to take the data from, and also the path that we need to write the data to. And also we need to do the configurations that we did to access the containers, to access the blob storage actually. So we have to rerun the code again. So first let's run the configuration here. Let's name it configurations. And let's say first let's configure for the configurations, we need the storage account and storage account access key, which we already used in bronze path. I mean the bronze code, which is this configuration setting. So we're going to use the same in the silver too. And then we need to specify the bronze path, which is like this one. Oh, which we already have in bronze too. So I'm going to copy that as well, the bronze path as well, into the silver. So I'm going to paste that here to have the bronze path, but we also need the silver path equals. Why am I writing all this? You can just paste it and change name from bronze to silver, and then at the end change bronze to silver. So that's it. So we specified the path that we need to read the data from, and we also specified the path that we need to write the data to, and we also have the access. We also configured the access to that storage account. So that is all done. And now we need to read the data. For that, we do df bronze equals parenthesis spark dot read stream and format. So here the format is delta, because we wrote the data in delta format, so we need to read the data from bronze as delta too. So delta code and then dot load of bronze bronze path. Let's separate them line by line so you can read it. So this, like we already said, this is to read the data from the bronze directory that we stored the data in. So we use spark.readStream to read the data in the format delta, because we wrote the data into the bronze directory in the delta format. So we need to read the data as well in delta format. and we do load bronze path to start loading that. So for the steps for cleaning, we don't actually need any cleaning except for one or two, but because here we are simulating the data and we are generating our own data using a faker and streaming with Kafka. So we are generating the fake data and we know what data will be in that data set. But because this project is a simulation of real world project, so we are going to do a basic cleaning that needs to be done on every data that we get. Let's say here we know the data source, we know the data that we get, but in real world, we know the data source, but we don't know the data we get. It can be any data, it can be null values, it can have a lot of errors, it can be outliers. But so for, for this project, let's just assume our data is not clean and do the basic data cleaning here. So for the cleaning step, let's put the heading as clean and enrich and assign a variable name for the cleaned data. That's df underscore clean parenthesis. So the data is in df underscore bronze. Let's say with column parenthesis time stamp code to timestamp of code timestamp code parenthesis close. So in this step, we are defining the data type of the timestamp column, because in the bronze code we never defined the timestamp column as timestamp. We defined it as a string, but now we define it as a timestamp because we can use some functions and methods that we can use on the timestamp, like timestamp windowing, like that, some stuff like that. So we're defining the timestamp from string to timestamp, and also say with column of price. Let's put double quotes as well. Price code then of COL of price is null, parenthesis open, parenthesis close, comma 0, comma 0. Dot otherwise parenthesis open, call of price, parenthesis close, parenthesis close. So in this line we are saying if the column price is null, so if the column price is null, assign 0.0 to it, or otherwise just put the real value of the price in that. So we don't actually need to do that on our data, because we know the price ranges from 10, I think it's 10 to 2000, so there is no way we get any null data. But just in case, just for the real world scenario, we need this as a best practice to have. And then with column of quantity, comma, when of call of
quantity quotes is null. So we do the same for the quantity as well. Let's say, but quantity can be 1. It should be 1. It cannot be 0 quantity, right? So otherwise, say call of quantity. Okay. So we're doing the same thing with the quantity as well, but if it is null, it assigns 1, otherwise it assigns the actual quantity value. And then we have with column of total amount, it's total amount. Not sure if I'm spelling it correct. Total amount. Call of price. Asterisk. Call of quantity. Forgot to close another parenthesis. So here we already have total amount column, and we already calculated this while we generated while we used the simulated code in this particular line. We already did that, but it's just a best practice to have to make sure the total amount is correct. And yeah, so it replaces it basically replaces the total amount column with the new value and new column. It's just creating a new column here with the right price and with the right total amount value. And then here we can also drop duplicate IDs. Drop duplicates. Square brackets. Order ID. Close. So this line drops the if there is any duplicate IDs, it drops the ID. Drop the whole record. So in our case, we don't get any duplicate IDs because we are using the UUID 4. So it just generates a globally unique ID for every transaction. So there is no chance for us to get a duplicate ID, but this is also a best practice. And then we do a filter and say column of country. So most of our data is inside the USA. Let's say the data in silver table must be the data from USA. So I do that. So it filters only the country with USA data. And then I also filter of call of state of is not null. And here we just making sure the state is not null, because
at the final in our dashboard, I'm planning to create a map chart. So I'm just making sure every record has its state in it, and it should be in the USA. So the map can be a wide, I mean, a map can be compactable and very clear because it's just one country and should also have a state name, cannot be null. So this is basically the filtering, I mean the cleaning. So the cleaning is done. Now the clean data is stored in the variable df clean. Now we need to write the data in this df clean into the silver directory. So let's go ahead and do that. Let's name it write to silver layer and say heading to the top. And let's say df clean dot write stream dot format of delta. Format should be delta, and then dot output mode. So we all know should be append dot option of. So we do the checkpoint thing. Checkpoint location, checkpoint location, code, comma. This time it's silver path plus underscore code underscore no backslash underscore checkpoint code close bracket, and then we separate them into different lines. This one too. So that is it. So we define the configuration, we assign the path for the silver and the bronze, both of them, and we read the data from the bronze, and then we clean the data with these 7 steps. We cleaned and filtered and removed duplicates, and then we write the stream into the silver path and with the format delta and output mode append option checkpoint location for the checkpoints. And now I think we're done here, and let's go ahead and create the gold notebook too. For the goal notebook, let's name it. So this is step 3. We say aggregated, AGG, aggregated to gold. And then the basic steps, which are from PySpark dot SQL dot functions import. Let's import everything, but we don't need types in this code because we're not assigning any, we're not defining any types here, so we don't need to import the types. And also in the silver code too, we don't need the types here, basically. I think we don't need the types here. We just need the functions here. And yeah, the gold. And
let's put the heading imports. And then we need to specify the path, of course, and the configurations. So we're going to copy that from the silver this time. We're going to copy the whole configuration and rename it. Paste it here. So this is same. All we need to do is, so we need the silver path too, but we can change the bronze path to gold path, and here bronze to gold. That is it. So we configured and specified the path to it, and then, so for the data we need to select only the columns that we need, and we aggregate the data. So we need to make it business ready. We don't need the columns that we don't use for the visualization. So we only need the columns that we need. So basically, I think it's better to window the time for 1 minute. I mean, it's better to window it to 1 hour, but I don't think I have enough data to run that stream for 1 hour. So I think it's better to run window the timings for 1 minute. So for every 1 minute, the transactions are done, will be stored, will be aggregated, and it shows the amount of sales that is done and the quantity. So I think that's better. So basically, the columns that we're going to get after the gold, I mean into the gold tier are the time of the window time, the start time, and the end time, and then the state. And I think we don't need the country. I think maybe the country, and then the amount of sales and the quantity are the only columns that we're going to use. And that's it. So first, let's read the data from the silver path. And let's put the heading as read from silver. The code be, let's say, df underscore silver equals parenthesis open spark dot read stream and format of delta and dot load of load of silver path. So for this final step of the data processing, we're going to it's better to have total sales done and total quantities sold per state per minute. I've thought of doing per state per hour, but in order to do that, I have to make the stream run for at least a couple of hours to get the data. So it's better to group. It's better to do a window for 1 minute. So let's go do that for total items sold and total sales done per state per minute. So let's put the heading as aggregation. Oh, that's messed up. Aggregation. Let's say total sales and total items sold per state per minute. So firstly, let's say df gold equals to parenthesis open df silver, silver dot with watermark of timestamp code, comma 1 minute, then dot. So with watermark, so we did used with watermark. Oh shit! Is that 1 or an 8? Yep. So that's 1 minute. And then we do group by of window of timestamp code 1 minute, comma, we group by the time and we also group by state. So that's good. So we're done with the group by, and we aggregate now HG of sum of total amount of that. We're going to alias that with total, the name total sales. So we're going to alias that with the name total sales, and then we do sum of total, no, sum of, what was the name that we used? Quantity, total quantity, and we are going to alias that as total items. So we have created that, and we select now, select dot select of column of window dot start of dot alias with, let's just say window underscore start, say column of window. Oh, I forgot the quotes on the top. Window dot end parenthesis with the alias of window window underscore end, comma, the comma here too, and state, comma, total sales, comma, total items. So we're basically aggregating the total amount and total sales done and total the quantities, the items sold per state per minute. So I think that's an efficient and compact way to get the business outcome. So this we're going to use this table as our final business ready table, and we're going to ingest this into SQL warehouse in the next step. So first we're going to do, so we have the table and we're going to write it into the goal layer. So hash write to goal layer. We say if gold dot write stream. Here I think I need to add a no, I think yeah, no, that's it. So we do df gold dot write stream, and format. The format should be delta, and output mode append, and option, of course. Option should be checkpoint location, comma, goal path plus backslash underscore checkpoint code, and then dot start of goal path. So here we basically like we did in the previous codes, we just writing into the goal layer using that code. So I think we're basically done with the goal code too. So let's go ahead and activate the cluster again. So to activate it, go to compute and activate. So if the cluster is turned on, now let's go and run the silver code block first. Go, it is connected. So it is connected automatically. So now run the code. Oh, we got an error. So it says invalid decimal literal. Says column quantity is now 1. Oh, it's just a parenthesis. Okay. So accept it and run. Oh, I forgot a parenthesis here. Okay. Another error. Name to timestamp is not defined. Oh, I spelled it wrong. Should be timestamp. And now what? Oh, it's supposed to be capital M. I think now it's working. Just Let's see if it works. df silver spark dot read dot format of delta code delta dot load of silver path of display of df silver. Be something with, I mean, it's not looping, it's just executing once, so it should be somewhere in the loop. Oh, in this I forgot the last line. Says you need to say start of silver path branches class. So now I think this should work. So parenthesis here. Can't extract a value from state, need complex to extract. Okay, run it. Now it is running. Took a long time to run. So here we say reject, because now it runs. Let's do that after the job is done. Okay, now it is executing. So the data should be already injected into Silver table. So let's run this to see. And now it says incompatible format detected. What's wrong with this? Try df silver dot display of. Did this works? Okay, it did work. So we have the cleaned data here, which is our silver layer. And as we can see, the country is just common for everything. It's just USA. So we took out this. Okay, so we have the data in the silver table too. And now let's go ahead and run the gold table as well. And it is not connected, so we go ahead and connect it to our cluster. And now run. Oh, there is an error. Okay. Invalid syntax. What is it? Dot group by. Oh, I put a comma here. Sorry. So that's invalid. Okay. I took out the comma. And another error. Format delta. Put more append. Oh, I think I forgot to put them in the brackets, in the parentheses. I think they should be in the parentheses. Now let's run. The name state is not defined. Name state is not defined. Should be defined. Oh, wait. So it's supposed to be a variable. I mean, it's supposed to be a value. I mean, it should be in the double quotes. In the quotes. Okay, so that is it. Oh, here too. I forgot the double quotes everywhere. The same thing. So too many errors. I shouldn't be getting. Okay. Now it runs. So here we should be able to get the business ready table now. So let's write another code to see if it's working. We say df gold equals spark dot read dot format delta dot load of gold path df underscore gold dot display off. So this should display a table of records. Okay, so now we got almost 59 records, and every single one of them is grouped by state and the time. Yep. So everything looks good. So yeah, that's it with the codes. Now our next step should be uh, pushing them into the Git repository. The codes that are in here, let's go just create a file for them, for every one of them, but not the credentials. So these should be taken out. This should be taken out and say, copy this here. So this should be, these are the credentials for our own namespace and GitHub, Git Event Hub. I mean, Event Hub. So we don't have to save them as is. So we take that out, and also this one. For that, I'm going to copy this and paste it. So we're basically creating files for all the three. Wait. Copy, paste it. So we're basically creating three files for all three codes that we did for bronze, silver, and gold, and pushing them into the Git repository that we created in our system. So this is it. And we took out the credentials, our credentials, and bronze path. And I'm leaving the rest as is and saving it as the C drive, users, J, in our repository, in Databricks notebooks, and save as type all files, and name it O1 copy paste this. Copy, paste it, save it here, and do the same thing for the rest. So I'm going to do the same for the silver table too. To copy that. Oh, it says the cluster is closed because it just terminated. I clicked terminate like 5 minutes ago, and now it is terminated. It took time. Okay, so I'm going to paste the code here, and the credentials should be taken out right here. So the credentials will be taken out, replaced, and it's saved as the same name. And type all files, save. And for the goal table, save as. Let's see. So in our repository, we should have all the files in. Oh, I accidentally saved this as text files, so I have to change them. Save as. And at the end, it should be .py. So now I think, yep. And let me delete this text files real quick. So we have the 3 files saved in the Databricks notebook folder. So we're going to push them into our Git repository, Git local repository. So I'm going to open the Git bash and say cd real-time e-commerce insights Azure / Databricks notebooks, enter. So it is in that folder now, and now say git add. So I'm going to add one by one just to make it clear. So I'm going to add the first file, stream order bronze. So you want to copy that. Oh well, I can't copy that into git bash. It's easier to type in the git bash than copying it. So I'm going to type it manually. Orders 2 once .py. So we added that file, and we now need to git commit with a message -m -m and say inserted raw data into blob. Says inserted raw data into blob, one file changed. Next we add git add o2 underscore cleaned silver, cleaned value silver, clean value silver py. It is added, and now git commit inserted clean values to silver layer. Like I said, we are adding them separately just to make it clear. So whenever we look back at the transactions that we'll know. So at this version, we did the bronze, we just put the raw data at this transaction, and at this transaction we did the silver data. So in case we want to go back in time, so we can go back to that version where silver doesn't exist. We add git add o3 aggregated, say aggregated to go dot py, and then we do git commit with the message aggregated data added to goal layer, and one file changed, so we push that to local book repository. Now we're done with that. And now we're done with the data processing. We came all across producing the raw data, streaming it, and processing it, and we have the business ready table stored in the goal layer. And now all we need to do is pull the data out from the goal layer and store it in a catalog in the Databricks, and then use SQL Warehouse to query that into Power BI. So for that, let's go ahead and create an SQL warehouse in Databricks. In Databricks page, on the left pane, under the section called SQL, you can see an option named SQL Warehouses. Click on it and click Create SQL Warehouse. Name it e-commerce. I'm gonna name it e-commerce SQL Warehouse. And cluster size, let's say 2x small, because we don't have too many records, so the cluster size 2x small is just fine for us. And auto stop, let's set that for 10 minutes, and scaling is 1:1, that's fine. And the type is serverless. Hit create, and this shouldn't take much longer to create a warehouse. And now it's active and running. At this stage, you have to head back to the gold notebook that you created here, let connect, and now create a new cell and switch it from Python to SQL. And here we're going to create, let's say, create or replace table, and we're going to specify the path just in case. Default dot, name it gold order
managed, maybe. Oh, I'm gonna do that in lowercase. Gold orders managed. And at the bottom, say as select all from delta dot. So here we're not going to use quotes. We're going to use backticks, the button that is right under the escape button on our keyboard. So we're going to use that. So and now we need to head back to workspace. And no, sorry, we don't need to head back to workspace. So that I was confused. So we don't need to head back to anything. Right here in this notebook itself, we have the configuration right here. So we copy the gold path that we specified before. We're going to copy that, copy and paste it in our query. And here, so we are using SQL in this notebook, and we're creating or replacing if the table is already existed in that destination, and we're creating a table in the path default dot gold orders managed. Just says default because by default the base catalog is e-commerce Databricks because that's our workspace. So we specifying the next one as default. So we are using the default database, and we are creating a table inside the default database named Gold Orders Managed, and we are aliasing it as the file path that we specified, which is our goal table, and we are saying the format is in Delta. That's how we create a table inside the catalog. And now let's go ahead and run it. So if you see this screen, that means your code is the query is successfully executed. We can check that by going to the catalog here. You're gonna see 4 options. Click on the third one that says catalog. Click on it, and go in under the My Organization section. It shows our workspace name, which is e-commerce Databricks. Under that, under the default, we created gold orders managed table, and with the columns that we already specified while creating the gold table, which is window start, window end, state, total sales, total items. So the data should be successfully entered into that particular table. To check that, and to check if our SQL warehouse can successfully query that data, in the left pane, click on the queries that is under the section SQL. Click on queries, create a query, and name this query with something that you like to go. Let's say gold warehouse. It's a gold warehouse. And here to select all from, and the table name that is gold orders managed. So right here, click on it and run this query. We need to first connect to the SQL warehouse that we created. So click on the connect button and click on the warehouse name that we created, and it is now connected. And now run that query. So here we can clearly see the data that got ingested into that warehouse. So it is now ready to connect and pull this data into Power BI. So let's go ahead and open Power BI desktop. And click on get data from other sources. Here, go to Azure and Azure Databricks and hit connect. Here it asks for server hostname and we also need HTTP path. For that, we head back to Databricks and go to the SQL warehouse that we created. Click on the three dots. Now, click on the name itself. And here we can see the connection details in the connection details section. Copy the server hostname, paste it in the hostname, and also the HTTP path is also here. Copy, paste it, and just leave the other optional things empty. And here, data connectivity mode. So you can do import mode, which is separated from the SQL warehouse environment. So it just pulls the data once, but the direct query once is an active one. So it pulls, if the data in the SQL warehouse changes, the data in your Power BI also changes. So in our case, we are trying to make it a real-time project. We're gonna use direct query here and hit OK. We have to sign in with our Microsoft account, and that account should be same account that we used for Azure. So now we logged in with our Microsoft account and we can connect. And this pulls all the catalogs that are in our Databricks into the Power BI. And we can choose the data we need. In our case, we stored the data in e-commerce Databricks workspace. Under that, under default, and under that, the table named gold orders managed. So it pulls all the data that is in this table here. So, and we got all the data we need. And then we need to click load. Now it loads all the data. And that's it. You got your data into Power BI successfully. At this point, we completed the whole data engineering part in our project. And we only need to create a dashboard. For now, let's create a simple dashboard that looks good. For that, let's just first create a layout to insert shapes. Let's use this one. Go to format, rotate, angle to 90 degrees. Just do this like that. And for the color, we're just going to do white and hit more colors. Make it a little bit gray. Just a little bit gray. That's it. And no border. Turn the shadow on. That looks good. And do another container. So now we're just gonna do the layout first and put the charts in later. And for this, we can do 4 KPIs. So I'm going to do 4 blocks to put the KPIs in.
And for the style, let's do the light gray that we selected. No border, shadow on. Copy. Now here in this block, let's add a KPI. For that, we go to the card option here and select the total sales. So this pops up with the total sum of the total sales, which is 1.03 million in our case. And let's just format it. Effects, turn off the background, and try to fit it in there. It is so big. So we need to first I think we need to reduce the size first. That we go here and we select let's say 30 for that fit. Maybe 25. Yep, perfect. And for the category label, let's just make it to 8. That fits perfectly. A little bit to the top. That's perfect. And now we're going to group them. We hold Control and select the both tables and right click. So we need to hold Control and we need to select the top layer first and then the bottom layer. And on our mouse, we need to click right. We need to give a right click and click on group and group. So these both are grouped now. So whatever you do for the back layer, the both will change. If you move one thing, both will move together. So that's how the group works. Now we're going to copy paste it 4 times. This is a little off. That's great. Another one. And we're going to choose this one. And for this, we're going to click the drop down here and select average. So this shows the average of the total sales that is done. And the first block shows the sum of total sales. And for the third one, we're going to take this off and select total items. So this is the sum of total items sold. And for the fourth block, we're going to take the sum of totals off and click on total items. And at the drop down, we're going to select the average. So this is the average number of items sold per order. So these 4 are our KPIs. And now I'm going to create another container. Shapes. This one. Or else I just need to just copy this. Just back. Copy paste it. But we need to take the inner container, that is the KPI. We need to take out the KPI from it. We just need the container here. Rescale it. And for the shape,
we change the roundness, reduce the roundness at the edges to make it look good. Let's do 6%. That looks good. Yep, that aligned perfectly. Let's create an area chart. And for that, we do timely sales. So we select the total sales and we select window start. And here we need to go hit the drop down button next to the window start. And we need to select window start, not the data hierarchy. Now we can see the line chart that is the area chart that is created. And of course, head to format section by axis. We don't need the title, but we need the values, and similarly we don't need the title for y-axis, and for the grid lines we don't need them for the horizontal and the vertical. And also head to general, effects, background off, make it fit in this container. Maybe like this. Perfect. Now select the top layer and the bottom layer. Right click, group. So they're grouped now. For the color, let's do navy blue. Head to format and should be in lines, all color, say to navy blue, and create another container, insert shapes, another container. Oh, my bad. You can just use the old container. You just copy paste it at the bottom. Align it. And then in this, let's create, before that, let's just create another vertical container right next to it. Choose it. Delete the chart first. Remove it. You just need the container here. Make it a vertical container. That's it. And now we're going to build a filled map. By the way, for the filled map, if you want to create a filled map, you need to make sure you go to Files, Options and Settings, Options, and in Global Options, go to Security. So you have to make sure this checkbox is turned on, Use Map and Filled Map Visuals. So this checkbox should be turned on. If it's turned off, you need to turn it on and you need to restart the Power BI, and then you can be able to use the filled map chart. So I already turned on, so I can use it now. For the map, we are going to select state and total sales. Okay. Let's just format this one too. Format, map settings. Let's change the style to grayscale, just to match with our schema, the color schema. And then fill colors. We'll change it later on. And then go to check. For the effects, we need to turn the background off. First, fit it in this container in the top section. Get a little bit wide. Perfect. And now go to the format section again, and in fill colors, we're going to use an equation, use an fill colors function. I think it's effects. Yeah, effect, not equation, sorry. So we click on FX, and for this format style, we choose gradient, and the fill, we're going to use sum of total, and the summarization as sum. We'll leave it as is. And for the minimum, for the maximum, let's choose our navy blue. And for the minimum, choose navy blue and hit more colors and make it lighter. Like this. That should be perfect. Hit OK. So the intensity of the color that is labeled for each state shows the which has higher sales. So the intensity is proportional to the sales that are done in that particular state. So this matches to our color palette. And now we're going to create another chart. Let's do another chart. Let's do a table. Let's just create a table, a normal table, which shows, let's say, window start. And we'll first change this to window start, and then state, total items, total sales. Perfect. And make it bigger. Format it. Style preset. Save it. Let's say none. For the general effects, background color off. Just try to fit it in here. To fit it, going to go into visual values, reduce the size, and also for the total, reduce, it's already to the least, and column headers, also reduce the size. Now it should fit. Just need to reduce the size for the vertical. Yep. Now that fits perfectly. So, so this table shouldn't be just a table. Let's make it something more different. So by adding a sort, we click on the three dots on the top, and we select sort by the sum of total sales, and it should be descending. So the highest sales will be displayed on the top. So this table has an impact on our dashboard now. And now let's create another container. Oh, I'm doing it again and again. I can just copy this, paste it, place it right here. I think we can make it bigger. Slightly increase the height. And remove the chart inside. Remove.
Let's create two donut charts, one for the total items, one for the sales. So for the donut chart, let's do total sales for per state. One one for total sales per state and the other one for total items per state. And here we're going to go to format again, general. Like I said, we need to remove the background to make it to blend in with the container. And then if we remove the legends, we don't need them. And then for the slices, for the labels, we go to options and label contents. Let's do category and percent of total, so that we can see which state represents which color and the percentage of that particular state is taking part of the sales. So that looks good. I mean, that doesn't look good, but that shows the right information in it. But now we're going to make it look good. Head to slices, click New York first, and go to color, change the color to navy blue. We're making sure every chart aligns to our color palette. And now we also going to choose navy blue for this, and again go to more colors, but make it a little bit lighter than the other ones so that it won't mix it. They won't get mixed. So and to the other state, let's again choose this lighter navy blue and make it more lighter, and do the same for the other state. Make it even more lighter, and for the last, do the same. Make it even lighter. Perfect. Now we can make it bigger, I guess, like that. And copy and paste this particular chart right next to it. For total items here, for that we're going to choose the right side chart and go to visuals, the main pane, and take out the total sales and choose total items here. Now this chart shows the total items and this one shows total sales done. Now that looks perfect. The only thing missing is we can add the total sales KPI in the center of the donut. So let's go create another card for the total sales, format it, or else just format it. Go to general effects, turn off the background, reduce the size. For this, I don't think we need the label here because we do know the total sales done. But for the values, we're going to reduce the size. More. That should fit in the center perfectly. Yep, that's perfect. I'm going to paste this, and do the same with this donut chart right here. But I'm going to head to visualization and take out total sales and add total items. So
Now we have all the charts and KPIs lined up and it looks good. I mean, it's basic visualization and basic dashboard. For a basic dashboard, it looks good. But the only thing missing here is filters. Okay, let's add the filters now. Click on this icon that says slicer. Click on it and choose the filter that we need. Let's choose state first and click on format, slicer settings. Let's change it to drop down. Drop down should be good. And go to general, effects, background turned off. Let's place all the filters in this section right here, just to make it look good. That's perfect. The values, background is nothing, border is nothing. It looks good. So we copy, paste it just under that. Just under that. And for this, we go to values and take out state. Put maybe Windows Start. Just the minutes is fine, I guess. Yeah. We can't do that for the total sales because there are too many. So I think that's it for the filters. We only have 2. Even the Windows Start, we can do a filter for Windows Start because there are too many parameters that we need to deal with. I think we can take it off, we can remove it. Just the state filter is enough here. And yeah, that's it. I think that's pretty much it. I'm going to insert a text box. Let's say filters. Oh, the caps lock is on. Let's say filters. That's good. Small, bold, increase the size to maybe 16. And for that, effects, background turned off. Now I'll place it. Forgot how to actually. I actually forgot how to move it. Let's just move it this way. Right on top of it. Let's align it with the filter. Now that looks good for a basic dashboard visualization. So we're done with the data dashboard. You just need to save the file. Let's name it e-commerce dashboard. E-commerce sales dashboard, maybe. Sales dashboard. Save. Okay, now it is saved. And also, I forgot to show you the filters actually working. Let's see if they're actually working. Let's try Arizona. There you go. The map zooms in and The filter applies to every single chat and the KPIs. Let's say CA, California, Illinois, New York, Texas. So the filter works perfect. So we almost done with the whole project. I mean, we actually done with the whole project. The only thing left is to push the Git repository into the actual GitHub. And also, we also need to add this Power BI file that we just saved into. It is saved in the documents by default. We're going to copy that and paste it in our repository, that is in C drive, users, J, Power BI folder. Just paste it here. Now open git bash. File cd real time e-commerce insights Azure / Power BI. Git add e-commerce sales dashboard. Hit enter. Oh, I forgot to specify the file type. I forgot it. So it should be PBIX. So I forgot that. So add git add e-commerce sales dashboard dot PBIX. Now it works. So we added the Power BI file into our local Git. We need to commit the changes. Git commit with to them with the message. Let's say created the dashboard, say sales dashboard, Power BI. Commit the changes. Yep. And with that, we officially completed the last step of our data pipeline. So we completed our project. Let's have a recap of what we did. Head back to the data architecture, the pipeline architecture. So we generated the data, we streamed it using Event Hubs and Kafka engine, and we processed the data using Databricks, and we stored the data in blob storage throughout the data processing stage. And then we push the data, which is business ready, from the goal layer to SQL warehouse, and we pull the data from SQL warehouse to Power BI, which is our last step of the data pipeline. And then we created this good looking dashboard, which is business ready. By the way, I tried to make this video as short as possible and also try to explain every concept clearly, but this video is already past 1 hour. So yeah, I tried. And also I'm going to, all the commands and the codes that I used in this project, I'm going to upload them into GitHub repository, and I'll put the link for that repository in this video description. And with that being said, that's it for this video. Hope you guys enjoy it and hope I see you in another video. Until then, adios.